Hey, what's up, and welcome back to the multiverse of 100 plus data science project series. In this video, we are going to discussing about the rainfall predictions using Python and machine learning. In addition, you're going to using here the MLFlow and the Flask. So this is the demo website that you're going to building in this tutorial. So now let's test it out. Let's say for the pressure, let's give it here 1015, and for the dew point, let's give it here 19.0, and let's say humidity, let's say 95, and for the cloud, let's give it here, let's say 81, and sunshine, let's say zero point 0.0, and wind directions, let's say 14.0, and give it here the wind speed, let's say 13.7. And if I click on predict, then you can see here prediction result is called rainfall. And in this tutorial, you're going to building these full applications using Flask, as well as for the experiment, we're going to using here the MLflow, which one is advanced types of technique that is used in machine learning. So without wasting any time, I am going to start tutorial right now. First, I'm going to importing here the pandas, numpy, matplotlib, and the seaborn library. So let's import it here. Let's say import pandas as pd. Then I'm going to importing here numpy as np. Then import the matplotlib.pyplot as plt, as well as I'm going to importing here the cborn as sns. Okay. Then I'm going to set here some style. Let's say sns.set, and let's say style equal to, then I can give in here, let's say white grid. And after that, I'm going to set the style for the matplotlib. That's a plt.style.use. And then I'm going to using here the 5830. This is nothing but the style. Okay, thirty 30. Shift enter. Okay, and you can see here it is loading this all of the library in my Jupyter notebook. And after that, what I can do, I am simply going to load in the dataset from the directory. So that's our dataset. That's called the rainfall.csv. You can get this CSV file in my GitHub repository. Anything error? Okay, 538. Okay, it having error because it should be the 538. Okay, it should 5830 not. It should be 530. Okay, thirty 8, like that. Okay, fine. Now you see, you actually using the style of that. Okay, it will give you some kind of decorations in your visualization plot. Now I'm going to load our data set. Let's say pd.read_csv, and inside that, let's giving here the file path. Let's say rainfall.csv, because this is in my same directory folder. Now let's assign it to variable called, let's say data. So that's our data is loaded, and now let's say data.head. Then you can see here that's our data is loaded, having some column just like day, pressure, max temperature, minimum temperature, the dew point, the humidity, cloud, rainfall. Okay, important one. Then sunshine, wind directions, and the wind speed. So this is the rainfall that we need to actually predict. Okay, so this is nothing but one classification types of problem. Okay, classification types of problem. If I try to checking this one, let's say data of, let's say rainfall dot unique. Okay, and you can see just having two values, yes and no. That's mean this is an binary classifications. Okay, so you can check in the shape of that. Okay, and you see that this is the shape of our data set. It having the 366 row and the 12 column. So first what I can do, we simply going to do some EDA on our data, and as well as we're going to simply going to creating here one machine learning model. And after that, we're simply going to deploy it, or we're simply going to connect it in the MLflow. Okay, in the MLflow. And then we're simply going to collect the data or collect the model file from the MLflow to the Flux applications. That's mean this machine learning model model to MLflow. Then after that, MLflow to Flux, like that. Okay, that's mean we're simply going to deploying here. I mean building our machine learning model, and after that it can push it inside the MLflow, and from the MLflow we are going to building our Flux applications. Okay, that's the technique that we're going to actually use it here. Now we see the shape of our data. Now we can checking that how many unique value in our day. So let's say day dot unique. and we can see that all of the value is nothing but unique. It's starting from 1 to 31. Okay, nothing but a simple month. Okay, nothing but a simple month. So what I can do, we can simply going to actually do some analysis on the data, just like data.describe. For describing our data, let's say data.describe. Okay, and then you can see here the data. Okay, you can see here about the count, the mean, standard deviations, the minimum, maximum, 25% percentile, 75% percentile, and also the 50% percentile. And if I see in the transport format, let's say transport, then you can see here it's nothing but in transport matrix. That means it will reverse the matrix, right? Now we can also checking that the is there any categorical value or not. If I checking this one, let's say data.info, then you can see here all of the value is nothing but in the form of integer and the float. That's mean you don't have any categorical value. That's mean you don't actually handle this out. Okay, so now what I can do is simply going to uh, checking that columns, all the columns, let's say data dot columns. Okay, and inside that column we can see here it having some issue, just like it having some space. You can see here it having some space, and also it having some space also. Okay, so this space actually occurs some problems, so we need to also remove this space from this all other column. Okay, I think this is the problem of the human error. It can be happening some kind of spaces, so we can removing these spaces from this data set. Okay, so what I can do, you can using here, let's say data dot columns, and then you're going to using here a string, and we can simply going to using here a strip. So this strip method actually help us to remove the spaces or extra spaces from our columns. And now we're simply going to set it to our actual columns. Let's say data dot columns. Now if I check in this data dot columns, then you can see here all of the spaces is going to actually removing on here. Okay, now let's go on the next one. But before that, we can removing this DA, because this DA is not actually important here, because we know that in 30 or 31 days is completed for the 1 day, so it don't have any significant uh, informations regarding this DA. Okay, so now what I can do, we can check, we can do this. Let's say data dot drop. Okay, that we can using here columns equal to let's say DA, and then we can put it inside the same column. Okay, data equal to data dot drop, and inside this column we can giving here the data. Okay, fine. Now if I check in the data dot head as a data dot head, then you can see here this is nothing but our uh, data set. Okay, so let's make it df, because it's so boring to type here the data again and again. Let's say df. Okay, and df, and df, and this is also df, df, and the df. Okay, let's run it from the beginning. Now it's fine. Okay, any error? Yeah, except this axis 12 event, no new data has been, no elegant. Okay, this is happening just because we already removing this data from here, and also need to giving here the same thing. Okay, now it's loaded. Any error? Okay, it should be df. Okay, okay, now you can see here our df dot head, and we have the pressure and all the column except the day columns. Cool. Now let's checking here, is there any missing value or not. So first we checking that is there any categorical value or not. But first of all, you need to checking that is there any missing value or not, and after that you need to handle in the categorical variable. Okay, so what I can do, we can simply go to checking it using data dot isnal dot sum. Okay, it should be the df, not data. Okay, df dot is null dot sum, and you can see that we having one missing value in the wind directions and the wind speed. So what I can do is simply going to first checking the wind directions. So let's say df of wind directions, this wind direction, and checking for the unique value for that. So let's checking here unique value. That's a unique, and then you can see here those are the unique value. Okay, 80, 50, 50, 40, 20, 30, like that. Okay, that's the unique value. Now let's checking the unique value for the wind speed as well. This is the wind speed. Okay, so wind speed. So you can see here it is nothing but on fractional types of value or the floating point number. So what I can do, we can simply going to use the mode, okay, mode on these wind directions, and we can using here the median in the wind speed, because this is nothing but one floating types of values, okay, or fractional types of values. So for actually handling the missing value, we simply going to put it down. So what I can do, we can using a df dot, okay, df of the wind directions, df of wind directions dot fill now. That's mean filling the nan value, and df of this wind directions, and we're taking the mode of that, and after that we can replace it on here. If I copy this out, just to avoid, if I copy this out, this line, and if I go on here, and then if I passed here, then you can get here one value that's called mode is 20. That's mean using this 20, it will filling the missing value. It will fill in the missing value in the same column, we can go to paste it here. Now do the same thing, for the wind speed. Okay, let's copy this out, and I'm going to paste it here, paste it here, paste it here. This project is nothing but for actually make you understand that how the MLFlow work. Okay, this is nothing but simple projects. Okay, and now we need to take in the median of that. Okay, median, because this is an fractional types of point, we cannot taking the mode on that. Okay, so for the median, you don't need to actually giving here this one, uh, this index number, because if you remove this index number, you can getting here one kind of data frame. Okay, so that's why taking the first one. Okay, now you can see it will fill in the missing value as well. Now if I try to checking this one, let's say df dot is null, okay, not in null, actually is null dot sum, and we can see here you don't have any nan value right now. That's when we filling all of the nan value. Now what I can do is simply going to uh, we're simply going to handling the categorical value, because you can see for missingly we can see this categorical value here, objects. It is have one object that's been having one categorical value. So we need to mapping through that. Okay, we need to mapping through that. So how can I do that? Let's say go on here. Let's say data. Okay, it should be df, not data actually. Data or df dot columns. This is nothing but our rainfall column. So if I try to checking this one, let's say df of rainfall, and we already checking this out before, and we said that it's just having yes and no, and you can see just yes and no. Now what I can do, we simply going to mapping through these out. Okay, so what I can do, you can using a df of the rainfall, and we using here the map functions or map method here, and for the es, we making it 1, and for the no, we simply going to making it 0. Okay, in the same rainfall column. So you can pass it here, and here you go, we can removing this column because it's not needed at all. Okay, anything wrong? Okay, you can remove this one and also remove this piece from here. Now if I checking the data.info, or let's say df.info, then you can see here it is now converted into int 64. That's when we also handle our categorical value to the numerical value as well. Okay, we handle the missing value, that how can you actually replace the missing value, how can you handle the missing value, as well as we see that how can you actually convert the categorical value to the numerical. Now let's do some ed on that. Okay, also called the exploratory data analysis. Okay, let's take some shell. Okay, so what we have some columns. Let's say df dot columns. Okay, and those are my columns. So I am simply going to creating one list of this. That's the columns, and we can copy from here columns, and I am going to paste it here. Okay, except the rainfall. Okay, except the rainfall. Okay, and then what I can do, I am simply going to do one plot. So let's say plt dot figure, and inside that I can giving here one fixed size, let's say 15,10, and after that what I can do, I am simply going to creating here one histogram plot, or the hist plot. Okay, just going to creating here one kernel density. Okay, this kind of plot, so that you can see that the distributions of our data. Okay, you can see the distribution plot as well. Okay, using the sns dot heat plot. Okay, the histogram plot, just like that. Okay, so what I can do, we can using here for I in column. Okay, column in enumerate. Okay, because we simply going to enumerate all the column from our columns, and after that we can simply going to creating all of the plot. Okay, all plot for the all of the plot for the each of the columns. Okay, that's mean you don't need to actually typing here one column name again and again and creating the subplot, or the creating the actually hist plot. We can using here the for loop. Okay, we can using here the iterations method, and after that we can actually using here we can plotting here uh, in one single plot. Okay, so I giving here one, and after that you can giving here the subplot. So let's say subplots. Okay, subplot, and inside that you can using here let's say 3 by 3, 3 row and the 3 column, and inside that I can giving here the I. Okay, and after that I can using here sns dot hist plot. So using this one you can actually draw the histogram as well as your KD. Okay, you can also see the distribution of that. So let's say df of columns. Okay, and after that df of column, and after that I need to giving here the kt equal to true. Okay, so that you can see that how the data will look like, and then you can give it your title. Let's say plt dot title, and inside that I need to giving here let's say distribution of this column. So let's say column column column. Okay, then after that I can giving here the title level. Let's say plt. Okay, it should be here plt dot title level, title layout. Oh, here you go, and then let's say plt dot show. Okay, it will take time because any problem, number must be an integer with number this one not 10, but it will showing the result. So why this error? Let's see. Okay, subplot here. Plt dot subplot equal to 3 3 comma 1. I is nothing but coming from 1. So why this error? But we can see the distribution plot here. Okay, we can see the distribution plot on here. Okay, but why this subplot error? It said that 1 to number 9 not 10, number must be an integer with 1. Okay, it should be the pressures, the maximum temperatures, sunshine. Okay, it's having the 10, so that's why this problem actually happening out here. So we can removing the one, let's say removing this one directions, and now let's see. Okay, then you can see, hope so, the plot. Okay, distribute the wind speed. We can also give it here. You can also give it here. Just you need to making it let's say 3 by 4. Okay, and then you can see that because this should be problem of the subplot, because you give it here 3 cross 3, that's mean 9 value you can put it down here, but you give it here the 11s or the 10 values, it cannot fit. Okay, that's why this error. Now you can see the distribution is looks like the normal. Okay, having some exponential as well, but okay, it's fine. Okay, now let's try to actually explore it more and try to do the first count plot. Okay, but I see that the distribution is really good on here. I don't have any error. I don't see anything else here, so that yeah, we can also normalize the data, but I don't think that is important on here. Okay, let's check on that first. Let's first try to checking thus our target column, is there any imbalance or not. Okay, so let's say df of, okay, we can do the plotting. Okay, so what I can do, we can using a plt dot figure, and then we can give it here fixed size. It's nothing but let's say 6 comma 4, and then I can using here count plot. Let's say sns dot count plot, and inside that x I can giving here the rainfall, because in our data not also checking that if the data set is balanced or not. Otherwise you need to also handling this out. Let's say data equal to df, and then I can giving here on title, and then I can giving here let's say distribution of, okay, it should be count of rainfall. Okay, uh, rainfall. Okay, let's say rainfall data, and then we can give in here plt dot show, and you can see here count of the rainfall. See how it actually building on a machine learning model. First, in the first checking for the pre-processing technique, just like the handling the missing value. Let's say handling missing value. Then it is checking that if the data is normalized or not. Okay, no, not like that. First, then you will be checking here categorical value having or not. To convert them to the numerical. Okay. Then you know the checking for the KDE, or you can say the how the distribution actually look like. You need to do the normalization or not. Okay, but by default you need to do that. It's very good technique to use. Okay, and then after that you need to checking here if your data is imbalanced or not. Okay, so you already checking all of them. Okay, we handle the missing value using mode and median method, and then we also convert this categorical to the numerical, just like our rainfall class. Okay, using the map method, and then we also checking here the KD using the his plot, and the imbalance. Now you're going to checking this one. Yeah, it having some imbalance. I can see here the data is mostly just like 80 or 80 to 70% or like that, or 90% like that. So data set should be balanced, but it's now greater than, it's less than 50%. Okay, that's when data having some issue. I can see that, but better we can also actually checking this one later on, and after that you're simply going to handle this out. Okay, but after that you need to also checking here one more thing, that's called the feature engineering. Okay, that's called the feature engineering, which feature is actually important. So for that, for the imbalance, we're actually using the smooth. That's mean it can be the oversample, it can be the undersample. And for the feature engineering, we can using a different types of technique, just like the correlation metrics. Okay, first checking here the correlation metrics, and I'm going to making it markdown. Markdown should be okay. Okay, fine, not so bad. So let's say plt dot figure, and then I can give in here the fixed size, and then let's give it here 10,8, and then I'm going to use here the heat map. Let's sns dot heat map df dot core and not equal to true, and then I'm going to using here the cmap. Let's say color cool one, and then I'm going to using the fmt. Let's say 0.2f. Then add on title. Let's say plt dot title. Then let's give it here correlation matrix. Okay, matrix. I have some voice issue, so if you get any problem, so just consider it this one. Okay, and we can see our correlation matrix. Okay, so this is called the feature engineer part. So we need to take some features, which one is mostly correlated. We can drop the feature from here. That's mean let's say if the most of the column data is mostly similar to the target column, so we can remove one of them. Okay, so we can see that in these sections, this max temperatures correlated is nothing but one is nothing but the same columns, the 99%, 96%, and a 90%. That's mean how this max temperature is increases, this temperature is also increases. How the max temperature is decreases, this is also decreases. That means this is nothing but highly correlated. Same thing for the temperature, same thing for the minimum temperature, and also the dew point. You can see for the dew point is mostly similar, but this both three is highly correlated. So from the four, we can take in the three, we can taking the we're taking the one, and after that we're simply going to remove the three column, because all of the column is nothing but the mostly similar. Okay, how this max temperature increases, the temperature is also increases. Okay, mostly high correlated. So we can simply go to removing this from here. We can simply go to removing this column from here. But before that, we're also checking one more thing, another more thing, that's called the outlier. That's called the outlier. So which one? It's called the outlier. Okay, So let's see, is there any outlier or not? So for outlier, checking the outlier, we're going to using here the box plot. Okay, so let's go on the markdown. Okay, we handle this one, we simply going to removing this all the column, but before that let's first checking for the outlier. So what I can do, we simply going to copy this thing, and after that we simply going to paste it here, and instead of using the hist plot, we are going to using here the box plot, and we simply going to removing here this KD. And then you can see here the graph should be coming up here. Any problem, any problem? Come on, aha, come on. Okay, you can see here mm, you can see here uh, it having some outlier on the humidity and having some outlier in the wind speed. Okay, but most of the column it don't have any outlier. Okay, so you can consider this out, otherwise you can removing this out. But the problem is, if you removing this outlier from your data, that's mean you removing the whole column, sorry, whole row, not column, whole row. You have the less number of data. If I checking this one, you just having 366. You have the less number of data. If you removing this data, this outlier data from your data set, your data size should be reduced. Your data size should be reduced. So what can you do right now? You don't need to do anything else here. You don't need to do anything else here. Okay, so but now what I can do now, we simply going to removing this four feature: max temperature, temperatures, and the minimum temperature from here. Okay, so what I can do, we can using her data, okay, not data, actually df dot drop, and then inside that I can using here, let's say column is nothing but our max temperature, and then we can using here the temperature. Okay, it should be temperature. Okay, temperature, and then it should be the minimum temperature, because it's not needed. Oh, okay, you can taking this one as well. You can take let's say you take the max temperature and the temperatures and the dew point. You can taking this one, or you can just this, you can taking here the main temperature and accept them. You can delete all of them from the data set. Okay, this is called the feature selections. Okay, feature selection technique. Okay, now what I can do, we can pass it to our df, and that's our df. Now if I checking this df dot head, then you can see here it looks small right now. Okay, pressure, dew point, humidity, cloud, rainfall, sunshine, and the wind direction and the wind speed. That's mean we, those are the technique that I'm using it here. Handling the missing value, then categorical value, then we're checking here the KD, using the his plot, is there any distribution problem or not. Then we're checking for the imbalance data set. Okay, so then we're checking for the feature engineering, and we're also checking for the outlier. Okay, so now what I can do now we're simply going to checking here this one, that's called the data imbalance. Okay, so let's checking this one. So let's say df of rainfall, rainfall dot value count, and we can see here, yeah, data set is quite imbalanced. Okay, for the one it having the 249, and for the 0 is nothing but the 117, just like in the 50-50%. 50, not 50-50 actually, it's nothing but this one is nothing but just like 80%, and this is nothing but 20%, like that, or this is nothing but 70%, and this is nothing but 30%. That's when data is imbalance. Data is imbalance. Make sure that your the one, I mean the positive value should be the 80%. Okay, positive value should be the 80%, and this should be also be 80%, like that. Okay, mostly similar, but I see that, or you can say that 50, sorry, not like that actually. Your positive data should be the 50%, and your negative data should be the 50%. But right now this positive data is increases. That's mean, let's say I have one is nothing but, let's say I have 100, your 0 also be 100, but you have just 80, and for here you have just 20. That's mean data is imbalanced. Data is imbalanced. So now what I can do, I can simply go into using here one technique, that's called a down sample. That's called a down sample. You can also do the up sample. Okay, you can say over sample also that. So now what I can do first, I'm going to actually calculate the majority value from here. Then after that, we can using here this technique. Let's say majority. Let's say df of rainfall, okay, is equal to what? Because based on the class, you need to do the things, right? So calculate the majority. Now you need to calculate the minority. So let's say this should be the minority, and it should be the 0. Okay, so we calculate the majority and the minority. Now what I can do is simply going to downsample it using the random choice. So for that, you can using here np dot random dot choice, and inside that I can passing here my df majority dot index, and then I can giving here size of the length of the df of minority, and then is making the replace equal to true. Okay, replace equal to false, and then this is nothing but our downsample index. Down sampled, okay, should be down, let's say down sample indices, like that. Okay, that's been with down sampling our data. Now after down sampling, we're also joining here our majority value to the minority value. Okay, majority value to the down sampled data, sorry. So majority value dot lock, I mean locations, and in the locations we're simply going to passing here our downsample indices, and this is nothing but our downsample data. So it should be our df of majority downsample. Okay, now if you're checking the shape of that, then you can see here the data is look like that. Now the question is, sir, why should you making it downsample? You can also make it upsample. You can making it upsample, right? So why downsample? Because this having just less number of data, and this data is nothing but for the rainfall. So if you upsample it, it having some issue for getting some wrong answer. Issue of having wrong answer. Okay. So that's why what I can do is simply going to downsample it. That's mean having some data should be removed from here. Our data should be equal. Imbalance to balance means making it equality for 100%, 100%. I mean, not say like that, 50%, 50%, and making it 100%. Now df of majority downsample is nothing but the 1 on 7, and also the 0 is also 1 on 7. Okay, same thing. Now what I can do, I am simply going to combine it. Okay, I am simply going to combine it. So how can I do that? Combine it, pd.concat. I mean making one data set, right? Now inside that we can passing here our df of majority. Okay, pd.concat df of majority, and then we can giving here df of minority, this minority, and this is nothing but our down sample data. It's a df of down sampled. Okay, should be sampled. Okay, now we're simply going to sample it out. Okay, remove it out, and now we can simply going to, let's say df of down sample dot sample. Okay, that's mean we're simply going to shuffle the combined data set, right? Let's say frequency, so refraction point, let's say 1, and then we can giving here the random state, let's say 42, and then we're simply going to reset the index. Okay, just mean nothing but just shuffle the data, not should be in the same manner. It's the same manner for, let's say all of the is nothing but the 1 and the rest of the 0. Okay, it having some problem when actually creating the model is it should make sure be it can be the overfitted. So that's why we simply going to shuffle it. Okay, let's say drop equal to true, and then this is our df of downsampled. Well, now if you try to counting here the downsample data, just try to checking the head, then you can see that's our data right now. And if you're checking the rainfall value count, then you can see one more thing, rainfall dot value counts. Okay, and you can see one more thing, all of the data is right now downsampled. You can also do the Uber sample as well. Okay. Now let us start our model building. So what I can do now, we can start the model building. Okay. So we're going to using the random forest classifier on that because we could also do the hyperparameter tuning as well as you're going to using the MLflow. So your job is to following for advanced project and also apply here all the algorithm just like the logistic regressions with hyperparameters tuning, XGA boost, decision tree, and all of the model you need to using it here with the hyperparameter tuning because it's time consuming because I'm going to using here the MLflow as well. So that's why I decided to do it for the random forest. I'll show you just for one technique, then you're using here the another technique as well. Now let's say from sklearn dot model selection, I'm going to importing here the train, test, and split, and then I'm using here the grid search CB. Okay, grid search CB. Aja 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 beta. Bas. Then we have the cross validation score. Okay, cross validation score. Aja aja aja. Nahi aa rahe. Okay, cross validation score. Then from sklearn dot metrics, we can import here the classification report. Classification report, you can see classification report. You can importing here the confusion metrics. You can import here the accuracy score. Okay, and then from sklearn dot ensemble, you can use the tab key from your keyboard. It will go give you the auto suggestions. Okay, every time I find actually making this video, this kind of video, every time I told you that just press tab from your keyboard. Okay, should be classifier because this is a classification types of model. Now let's split it in the dependent and the independent features. So let's say x equal to df underscore downsampled because this is our data. Simply drop it out. Let's say drop of columns equal to, let's say, rainfall. So this will data will be go inside our x, and then except this one, it should be go inside our rainfall in our y. Okay, now we divide our data set into x and y. You can also using the iluck method, but this is the बहुत easy method है use कर सकते हो आप. Now let's using here the train, test, and split, and inside the passing here x and y, then test size, let's say 0.2, then the random state is nothing but let's say 42. Then I'm going to using it here, let's say x train, then the x test, then y train, and the y test. Cool. Now I am going to making our model. Let's say RF model. Okay, that's our random forest model, random forest classifier, and inside that I can pass in here the random state equal to 42. Okay, you can using this one and also do the predictions, but I am going to using here the hyper parameter tuning. So let's try to do that. So let's say param, okay, grid of the RF, and we are going to do the hyperparameter tuning using the grid sort CB. You can also using the randomized sort CB. So what I can do, you can giving here the number of estimator. Let's say giving here, let's say 50, 100, 200. Bas. Then let's give it here the max features. Okay, max features. So it having the two things. One is called the squirt, QRT, and another one is called the log base 2. Bas khatam. Then it having the max depth. Let's say none. Let's say 10, 20, 30. Then give it here the min sample split. Let's say 2, 5, 10. Then give here the min sample lip. Okay, it should be the, let's say 1, 2, 4. So that's our param grid. You can also using here this RF model and try to predict it. But why this one? Because we are going to using here the MLFlow, and inside our MLFlow we are going to passing this parameter, and we're going to also store it out. Okay, so why MLFlow, I'll discuss about that. Don't worry on that. Okay, now let's start using here the grid search CB. Let's say grid search CB, and inside that I'm giving her the estimator is nothing but my RF model, and then we have the param grid is nothing but my param grid RF. Then cross validation 4 is, let's say, CB equal to 4, number of jobs, let's say 1 or -1, बारबोस देखना चाहिए तुमको, देख लो बस. So that's our grid search RF. Let's say grid search RF. Okay, now what we can do, we can actually predict it, right? So we can using here, let's say grid search CB, okay, RF, sorry, and fit here the X train and the Y train. It will taking few seconds because it will fitting with the data. Okay, I'll be back on that. Now let's checking the best estimator. So copy this one, and I'm going to using here, let's say best estimator. Okay, so that's our best RF model. That means this is our model actually. Okay, so that's our model. We can check in this one like this way, and you can see that's our model. That's called random forest classifier, and mean sample is taking the 2, and the minimum sample split is nothing but 10, and estimator is 50, and random estimate is nothing but taking the 42. Okay, so now what I can do, we can checking, we can also printing here our best params. Okay, so let's say grid search RF, and then we can using here, let's say best. Okay, you can use the best params. Okay, I mean, how many parameter it have, you can see that max depth is nothing but nan, it say like that nan, max depth is taking as a nan, and max feature is taking the squared, min sample leave it will taking the 2, and minimum sample split it will taking the 10, and number of estimator is nothing but 50. Okay, now let's checking for the cross validation score. Okay, so let's taking some shell, and then what I can do, you can checking here cross validation score. So it should be the cross validation score, and inside that you can passing here our best RF model, and then we can passing here our X train and the Y train data, and as well as the 4 is, let's say 5-fold. So let's say CB of cross validation, okay, let's say CB score. It's not even the cross validation score, right? And we can printing it out. We can printing it out, and this is the cross validation score: 76% accuracy, 81%, 78, 83%, quite good, 81%. Okay, now let's start to taking the mean of that. So let's say NP of mean of the CB scores. Okay, CB underscore scores, that's mean 80% is nothing but our full accuracy of our data after the cross validations. Okay, now what I can do, we simply going to test the performance of that. So let's say best RF model dot predict, we can predict it in our test data. Okay, and that's our Y predictions. Okay, let's see Y predictions, and our prediction is coming up, and now we can show the accuracy score. Let's say Y test and the Y predict. So that's our accuracy score, 70% for the testing data. Now do the same thing for the confusion matrix. Okay, you can also do some pre-estimate on here, but I'm so lazy. So let's say classification report. So let's start running this out, and that's our confusion matrix, and that is nothing but our precision recall and the accuracy score. So now what I can do, I am simply going to store it inside a variable called report date. Okay, in a variable. Okay, and also I can give it here one thing that's called output dictionary is nothing but called true. And now if I try to checking this reput dictionary, now you can see here this all of the data, just like the precisions, recall, F1 score is coming up in a dictionary. Now, why dictionary? Because I need to passing this data in our ML flow. Now let's talk about the ML flow. So why we need to using here the ML flow? So let's taking one example. Let's say there are two data scientists. Let's say one is Mishu and another one let's say called Chandu. There two are a data scientist. Let's say DS, data scientist, DS. Okay. Now they actually both they working on a project. Let's say uh, credit card fraud detection. Let's say credit card fraud detection. Okay. They're working on these projects. Now for the credit card fraud detections, the Mishu is doing this work in a three notebook. Let's say notebook one, notebook three, then notebook. Let's say uh, okay, it should be two and it should be three. Let's say two and three. It having three notebook. Same thing for the Chandu as well. Let's say copy this out. Notebook number 4 and notebook number 5 and notebook number 6. Because this is a credit card fraud detection problem, so in the notebook one, let's say they're using here the oversample technique, and here let's say they're using here the undersampling technique, or they're actually using here the another kind of technique. Okay, now they go to the boss, and boss want them to give the solutions. Okay, then Misho go to the boss and say that, sir, this is the notebook number 1 and this is the accuracy for that, this is the precision and the recall for that, this is the notebook number 2, this is the accuracy and the precision for that, let's say 80%, 20%, and this is the notebook number 3, this is the accuracy, nothing but let's say 95%. Then same thing he go for the Chandu, and this is the notebook number 4, notebook number 5, and the notebook number 6, and boss is getting confused. So many notebook, so many accuracy, so many precision. Oh, it's better. I can see it in UI in the same applications. Is there anywhere? Is there anywhere? Mishi is also getting confused, but Chandu said that yes, it having one technique, we can using it here. That's called the MLFlow. Using MLFlow, you can passing your all of the notebook, all of your model with the accuracy in the same UI. And you can also do the compare of each of the model. You can compare each of the model. So that's why MLFlow is come into the pictures. That's when if you have the so many number of notebook, if you have the so many number of notebook, and you have you can get just like that, you have the confusion matrix, you have the accuracy, so to show it in one by one. So obviously boss is getting so worried that yes, I need to go on the notebook number 1 checking for the accuracy, notebook number 2 checking for the accuracy, again notebook number 3 for checking for the accuracy. So for removing this problem, MLFlow is coming to the picture, right? So using MLFlow, you can solving these problems. So now what I can do, I am simply going to installing the MLFlow. We can using here pip install MLFlow. Okay, for the notebook, you need to using here this one technique. Okay, pip install MLFlow. Yeah, it's already installed in my system. Okay, if I removing this one, you can also see one more thing that's called requirement is already satisfied. Okay, that's when it's already installed in my system, this MLFlow library. Okay, so you need to open your terminal. Okay, then you need to type in here one command that's called the MLFlow UI. That's MLFlow UI, and this MLFlow UI is opening in a server. Okay, in a local server or local host server. That's called 127.0.0.1 and the 5000. Okay, and you can see it's loaded, yeah, it's also installed. You can see a requirement already satisfied. So copy this out, copy this link, and then I need to go on here and I need to paste on here. Okay, and then you can see here this is the UI for the MLFlow, and you can see here it's having docs, it having the GitHub. You can go on the docs and you can read on that. You can also go on the GitHub. Now what I can do, you can also see here the models. Okay, you can see I already implement here 3 model. Okay, 2 model. Okay, no problem, I can delete it out. I can go on here and I can delete it out. Okay, I can delete it out. Okay, because you're going to making it from the scratch. Let's delete it out. Okay, now you can see I don't have any model right now. Let's call the register model. Now let's go on the experiment and let's creating here one experiment. Okay, now let's giving here a name. Let's call rainfall. Okay, that's just rainfall. Okay, and click on create. It will creating here one experiment. Let's call a rainfall. Now what I can do, I need to go on here this rainfall predictions, and I'm going to importing here. I'm going to importing here the MLFlow. Let's try to take in shell, and after that let's importing here the MLFlow. Let's import MLFlow, and also importing here MLFlow dot sklearn. So why sklearn? Actually, because we're going to using here the random forest, and this random forest is coming from the sklearn library. Now using this one, what I can do, we simply going to put the data in our MLFlow. Okay, that's our MLFlow UI, right? In our MLFlow UI, and then you can see your all of the accuracy, the precision recall, as well as you can compare the model if you have the multiple number of model, right? So you can see it imported. Okay, let's go on the full screen mode. Okay, so now what I can do is simply going to set our experiment. Let's MLFlow dot set. Then we're using here the experience. Sorry, not experience, experiment. Sorry, and inside that it's giving here the rainfall. So the rainfall, same thing, is nothing but here the same thing, same name. You have to give it here, not same thing actually. Rainfall. Actually having some issue on the for the cough, so that's why I can't speak so much actually. So MLFlow dot set experiment rainfall, and then we need to also set tracking. Let's MLFlow dot set tracking URI. It should be set underscore tracking URI, and inside that I'm giving here the URI is let's say HTTP. Then I can giving here let's say 127.0.0.1.5000. Okay, that's been this is nothing but our this link. Where is it? Yeah, the UI. You can see here. This is the link that is actually copied from here. Okay. Okay, so we're tracking the URI. Now what you can do with MLFlow dot start. Okay, start run. We're simply going to running our MLFlow, and inside this MLFlow we're going to passing here parameter. Okay, we're going to simply going to passing here the parameter. This param git we are going to passing here. Now this parameter or this parameter, which one? This one, best param. Which one? This one, because we don't need it. We need to passing here the best parameter to see the boss, because our boss is nothing but this one, boss, or to show the boss. Sir, this is the best parameter after the hyperparameter tuning. That's it. See, then we're going to passing here. Let's say MLFlow dot lock params. Okay, it should be lock underscore params. Okay, it should be params, and inside that what I can do, you can using here let's say grid search rf dot best underscore params. Okay, we're passing the params, and now inside MLFlow dot log matrix. Okay, log matrix, we're simply going to passing here our matrices. So our matrices is nothing but coming in here, our reports, in our report dictionary. Okay, let's copy this out, and I'm going to paste it here, then you can see that. So that's our report dictionary. And now inside our report dictionary, we have the accuracy. Okay, we have our accuracy. This is the accuracy. Where is it? Accuracy, precision, recall, support. Okay, you can see the accuracy. Okay, so what you can do, you can simply going to take in the accuracy. Now you know to giving here one name for that in the dictionary format. So let's say this is the accuracy. Okay, then after that what I can do, we need to having the recall. So we have the two recall. One is nothing but 0 and another one is 1. So what I can do, we can let's say giving one name. Let's say recall the class of 0, and we're taking it from the report dictionary from the 0th, okay, from the 0th, and from the recall. Okay, from the recall. And then after that what I can do, we need to have the recall of class of 1, and it should be the report dictionary of 1, and then we have the recall. Okay, and then what we have, we need to have the f1 score, Let's f1 score. Oh, f1 underscore score. Let's say f1 underscore score, and let's taking the macro one. Okay. Let's taking the macro awareness. Okay. So let's taking the macro, and then we're taking it from the report. It's a report dictionary, and from here we simply taking the macro awareness. Let's say macro awareness, and then from here the f1 score. Let's say f1 and then score. Cool. Now what I can do is simply going to lock our model. So let's say MLFlow dot sklearn dot lock model, and inside that we're going to passing here our best RF model, and then we're simply going to give it here one name. Let's call random forest model. Okay, random forest model file, like that. Okay, or let's say random forest model data. Okay, and you can see here it will tracking it out. Any error? Okay, resource doesn't exist, could not find the experiment ID is this one. Okay, I delete this out and try to running it again, and let's making it rainfall 1, and it doesn't exist. It will say it's maybe creating. Okay, you don't know to create it before, it will automatically create it. Okay, just avoid. Yeah, it's created, I hope so. Let's reload it, and yeah, you can see a rainfall 1. Okay, now let's go on here. You can have the your run. Now you can see here your run ID and your source, your locked model, and you can see the things that you can see on here. You can see here in the same file you have the accuracy, the f1 score macro, the recall class 1, as well as you can see here you have all of the parameter. Okay, now you go to the boss and so see that, show that, सर देखो देखो यहाँ पर क्या मैंने बना दिया. Okay, like that. Now the problem is if I go our models, you can see here any model. You can see here, you can see here the model, because you already passing here the model, right? This model we already passed here. This random forest model, I mean this model is passed here, but this model is not coming up here. Just we got here, we just got here one thing, that's called our accuracy and the parameter. But where is the model? Where is the model? गायब हो गया क्या? नहीं, नहीं. Because when you building any model, when you passing the model to the ML flow, you need to also register your model. You need to also register your model. So using code, you can do that. So you need to giving here a model name. Let's say model name, and your model name is same this model name. This model name, and after that, what I can do, you can giving here your run ID. Okay, your run ID. So your run ID, you can get it from here. You can see run ID. You can copy it from here, and after that you can pass it here. It's your run ID. Now you're giving here the model URI. Okay, your model URI. Follow this one. It's called runs. Then it will giving here your run ID, and then it will give it here your model name. Okay, your model name. It will follow the same the format. Now we can using here, let's say ML flow. Okay, with let's say with ML flow. Okay, dot start run, and then you can give it to the run ID is equal to run ID, and then after that we need to register our model. Let's say ML flow dot register model, and inside that you need to passing here the model URI is our model URI, and then name is our model name. Okay, any error? Any error? Invalid model version source runs this one. Random forest model to use the local path, the model version source, the run ID request parameter has the significant local path has been contained in the artifact directory, and the run is specified the run ID. Okay, so what I can do, we need to go on here and need to go on the rainfall, and that's our rainfall. Okay, is created on here. Status is failed, and then go on the models. Yeah, you can see here our model is created. Okay, yeah, our model is created. Let's give it here to one more thing, this one, and go on the models. Yeah, we have the models. Okay, then you can see here our models. So you can copy this out, you can pass it here. Okay, okay, I think I yeah, it should be the error because it also forget to give this one. Yeah, now it's fine, it is tracking the model. It's already existed. Okay, we registered a model on here. You can see if I go on the models, you can see the random forest model on here. That's when it actually इनको एक्चुअली क्या बताओ आपको, इंग्लिश नहीं आ रहे मुझे, सतर्क रहे के आपको काम करना पड़ेगा पर. Okay, because run id is nothing but this one, and it also giving her this columns. Okay, now our model is registered here. You can see our model is registered. If I go inside this model, and you can adding here one aliases, let's making here challenger. Okay, and save the aliases. Now using these challengers, we can simply go into making the model for the production level, as well as we can load the model file from here. If I go inside this registered model, if I go this model, you can see you can add in the descriptions, the text, as well as you can add here the version, and you can also compare them. If you have the multiple number of models, you can also compare them. Okay, as well as you can compare them with the other versions of the models. Now let's go on the experiment and go on the rainfall and go inside that. Then you can see the model matrices in the form of graph. You can see in the system matrix, it's not available on here. And now if I go on the artifact, now you can see here our model.pkl file is on here. Okay, model.pkl file is on here, as well as you can see our model, then conda.oml, then you can see here our requirement.txt file is also created. Now you can simply going to load the model from here. You can simply going to load the model from here. But how can you actually load the model from here? So you can simply going to load it the model using the run id, right? So let's try to go on here, and then I'm going to using here the run id. So for that I can go on here, and if I clicking this one, okay, if I clicking this one, and I can copy this one, let's copy this one, and I'm going to pass it here. This is a locked model, and instead of 5 punct you need to using here the sklearn, because this is a sklearn model. This is an sklearn model. Now inside is predict, I need to passing here our df. Okay, that's our df. Okay, now you can see it having some problem. Okay, not df actually, it is passing in the x test data. Okay, it should be the x test data. Now you can see here we pass here our x test data, and this is our predictions. And also our model is locked from our MLFlow. Okay, that's our model is locked from the MLFlow. Okay, so not locked, no, sorry, load model is nothing but our random forest classifier. That's mean, see, we passing this model file into the MLFlow. Now from the MLFlow we are passing our model file. Now we simply going to using this model in our Flux applications. Now the question is, sir, this MLFlow is running in a local server. Is there any way to upload it in a cloud server? Yes, it's possible. You can using here the DAX hub. But in this tutorial, I am not going to using it because it's already 1 hour long tutorial is gone. But upcoming tutorial, I am trying to creating here one extraordinary video using MLFlow and the DAX hub. Okay. Now we see that we can also load the model. We can load the model. Okay. Now using this model, we can simply going to actually do one predictive system. But before that, you need to also making this model for the production level. You need to using the model for the production level. So how can you do that? So you can using the challengers. Okay, if I go on the model, and if I go on here, and you can see using these challengers, okay, we can simply going to load the model. See how can you do that? So let's f. Okay, then inside that I can passing here the models and column, same thing. Then after that I can giving here the model name. In the previous the array is coming just because of this colon. Okay, and the model name, and after that I have to giving here the challengers. So let's say challengers. Okay, challenger, and that's our model is coming up here. So this is nothing but my car and model URI. current model URI. Okay, and after that I need to giving here one production name. So let's say production model name. Okay, let's give it here. Let's say rainfall prediction production, like that. Okay, now I need to creating here one client on that. That's a client equal to, okay, that's MLFlow client. Okay, MLFlow client. Now inside of a client, what I can do is simply going to copy this out. Let's say client dot copy model version, and inside the source model URI, we simply going to passing here our current model URI and DST. Okay, DST. Okay, destination name is nothing but our production level. Okay, production model. Now the question is, sir, why this production level and why into making it production level? Why? See, let's say we having different kind of version. We have different types of notebook. Let's see, this is the version number 1. It can be version number 3. It can be version number 4. It can be version number 6, 7, like that. So this alias is nothing but a simple name so that you can checking the version using this alias. Okay. This I make it challenges. You can give it here my name or your name as well. It's not necessary. Okay. You can give it here any kind of name. So based on this name, we can actually taking the version number 1. If it is having the version number 2, we can using here, let's say another name, let's call champions, and using this one we can tracking this model and try to apply it in our Flask applications. Okay, so now if I'm trying to actually use it, and you can see here we got again error, failed to pass the version of the model URI. This model called random forest data challengers errors, no proper models is found. Okay, if I go on here random forest model data, mode URI must be from the models or suffix or models of models name of the alias where the suffix is a model version or latest. Okay, so see challenger. Okay, let's checking this here. Let's say challenger CHA CHALLENGR, and this is version number 1. Okay, so see any error models f string, and then to giving here 1 slash again. Okay, then at the rate of challengers. Now you can see it coming up here. Now the question is, sir, you know about everything else, so why you are doing this kind of mistake every time? Why? Because this can be happen. This can be happen with you. First time while actually solving the problem using MLflow, this can be happen with me. It's happened with me. That's why intentionally I doing this mistake. Okay, prank tha. Okay, now you can see we actually removing these spaces. Now you can see here a model version is actually coming up here. Our model is version is coming up here, and if I reload it, you can see you can see anything else. But if I go on the experiment, then if I go on here, then you can see it's finished. So it's finished, and you can see all the things. Okay, you can see registered model is right now rainfall predictions productions. You can see on here. Okay, now if I go on the models, you can see here this is nothing but in the production model. Okay, in the production format. Now you can simply go into, you can go on here, and let's give it here one alias. Let's say call champion. Okay, now let's try to loading the model. Let's try to load the model. So what I can do is simply going to give it here one model version. Let's say model version, let's say 1, and after that we need to give it here production model URI. Production model URI. This time I am not going to do any mistake. Okay, so that's the models. Okay, then I have to give it here 1, and then I can use the productions, our productions model name, and then I have to give it here the champion. Let's say champion. Okay, champion, and then I can load our model. So let's say loaded model MLflow dot sklearn dot load model. Okay, and inside that I can give it here my production model. Okay, that's a production model URI, and then after that I can go here our prediction. Let's say y predictions equal to loaded model dot predict, and inside that I can pass in here our x test data, and then I can shift enter. Now you can see it's down in the artifact. Now if I check in our predictions, then you can see the predictions. Okay, this is nothing but in the production model, production types. Okay, let's say you have the multiple number of version of a model. So how can you do that? You can fetch it like that. You can give it your version number 2, version number 3, like that, and you can actually simply going to load the model from here. Okay, now we have our model. Now what I can do is simply going to creating here one predictive system. You can simply going to load it. Okay, you can giving here one input here, and after that you can actually you can simply going to actually do it out. So let's try to create one predictive system. Let's say predictive system. Okay, so let's say we have an input df, and inside input df we having some value. Let's say 1015 dot 9. Then we have the, let's say, 19.9. Then we have the 95. That's 95. Then let's say 81. Let's say 0.0. Let's say 40. I'm taking it out from the CSV file. Then 13.7. So those are the value. This is nothing but input df. Now what I can do is simply going to convert them into data frame. That's the pd dot data frame, and inside that I'm going to passing here my input data. Let's say input data df, and then I'm going to give it to the columns. That's the columns. So what are the columns? So we can copy it up from here. Let's say here we can copy this out. Okay, we can do one more thing. Let's say df dot columns, and you can copy this out. Pressure the this one thing, and accept the rainfall. Okay, accept the rainfall. We can copy from here. Okay, here you go. We can paste it here. You can paste it here, and also removing this rainfall. Okay, and then this is our input df. So it's our input df, and after that what I can do is simply going to using our loaded model. Let's say loaded model dot predict our input df. Okay, input df. Okay, and that's our predictions. Let's say prediction. Okay, our prediction is coming up here. Now what I can do, we simply going to printing it out. Let's prediction is nothing but coming here 1111 like that. Okay, so that's our input df in a data frame, and then we simply going to say that if the prediction is, let's say, printing here. Okay, anything else, any problem? Okay, not okay. So let's say print here. Let's say prediction, let's say result, and then inside that I'm going to passing here, let's say if it is a rainfall, let's say rainfall, then if it is nothing but predictions of 0 is equal to 1, else we're simply going to be taking it, let's say no rainfall. Let's say no rainfall, and then you can see prediction result is nothing but the rainfall. Okay, you can also save your model in the pickle format as well, but we are going to load the model directly from the MLFlow. Okay, in our Flask applications. So now let's start building our Flask applications and try to checking that out, that how can you load the model from the MLFlow, as well as how can you create the applications. Now it's time to creating here our Flask applications, and this is the code for that app.py file. Here we are going to write here our server-side code, and also inside the sections you can see here we have a folder called templates, and inside this template we having our index.html file. Okay, so what I can do is simply going to run in these applications, and after that we are going to go on our index.html file and try to see that how the UI is actually built. It's super simple. It's not so hard to do. We simply going to using here the bootstrap on here, just simple bootstrap cdn, and after that we're simply going to adding here one title, and then adding some input text. Okay, it will down the artifact, and let's go on the link. Okay, you can see this server is link is running open is 8080, but when you're not giving here any port number, it will by default running in the 5000, so it will some deprecated with the MLFlow. Okay, you can see here this is our UI. It is having one neighbor that's called rainfall predictions, and you can see here one simple types of card, and inside this card it having pressures, the dew point, the humidity, the cloud, sunshine, and the wind directions, and as well as the wind speed, right? So when a user clicking this button, and it will automatically actually show it just nothing but uh, our result. Okay, so now what I can do, I am simply going to go on the index.html file, and after that I'm simply going to uh, make you understand that how the UI actually building. Okay, so that's our index.html file, and inside this index.html file we having our bootstrap is linked, as well as you can see here we having one navbar that's called the rainfall predictions that you can see on here. Okay, and after that you have simple one card, and inside this card you're having one hport tag that's called the predictions of the rainfall, and after that inside this card body we having one form, and inside this form you can see here action is nothing but the predict, and also method is nothing but the post method that you can see on here. Then we're having simple on deep, and inside this deep we're having one label and one input. Okay, one input tag, and inside this input tag we having one key that's called the name. Using this name we can actually get in the data, or we can get the data from the users to this name to the server side. Okay, so how an user actually give the value for the pressures, it will taking this value using this name, using this name tag, and after that it will go to the server. Now do the same thing for here, same thing for here, same thing for here. Okay, all of the things equal sunshines, the wind directions, and the wind speed. And after that you having one button for the form, which one is a submit button, and button name is called the predict that you can see in the UI. And high end the prediction is coming up, high end the prediction result is coming up from our app.py. Just seeing this result, that's called the it can be the rainfall or the no rainfall. Now let's go in our app.py file. So first we importing here the Flask. From Flask we import the Flask and the request and as well as the render template. So Flask is nothing but for creating our Flask applications, and request is nothing but for taking the input from this name keyword. Okay, so using this one we can taking the we can passing the data from our UI, and after that we are having the render template which one help us to render in the template from our templates folder. Then you input the pandas and also the MLFlow.scalar. Okay, then we initialize here one app, you can see initialize here app, and after that we are going to loading the production model. Okay, that's our model name. If I go on the MLFlow, then you can see that's our MLFlow, that's our production level model. Okay, you can see rainfall prediction productions, that's our model. And then we simply going to load the model using our model URI, and after that we're giving the features name that's called pressure, dew point, humidity, cloud, sunshine, wind direction, and the wind speed. And then we're simply going to creating here one initial route that you can actually see on here. That's our initial route. And when the user clicking on the predict button after filling all of the form, it will go to this predict actions, and it will also checking for the post method. Okay, and if the method is nothing but the post, then it will take in the data from the users, and after that it will take in the data from the UI using the request.from, okay, from method. And after taking this one, it will pass in this data to the data frame, and also using loaded model we need to do the predictions. And after that if it is equal to 1, it's called the rainfall, otherwise it's not no rainfall. Then after that we're simply going to pass in this data inside our prediction result. Okay, inside our prediction result. So this prediction result is taken from here index.html, and it is coming up, then it will show the result on our UI sections. Okay, simple thing. Otherwise if there any error, that will show the error in the exceptions. And also you can see here we give here the port number is called 8080. If you're removing this port number, so your MLflow port and as well as your Flux application port should be the mismatch. Okay, कोलेशन हो सकते हैं यहाँ पर, इसलिए मैंने पोर्ट नंबर चेंज कर दिया यहाँ पर. Okay, बस. So now if I go on the applications, and if I let's say give it a pressure, let's say 1015 point, let's say 9, this is the pressure, and let's say dew point, let's say 19.9, and let's say humidity, let's say 95, then cloud, let's say 81, then sunshine, let's say 0.0, let's say wind directions, let's say 40, and that's the wind speed, let's say 13.7. And if I go on here and try to click the predict, then you can see here it's called rainfall. Okay, this is how the application actually working. Okay, you can see prediction result is rainfall. So if I go on the simulations tab and open the mobile simulator, then you can see that how it look like in the mobile simulations. And as well as you can go on the, let's say, iPhone 12 Pro Max. Okay, this is one. And if I go on the MacBook Pro, then you can see that how it will look like, and as well as the iPad Pro 11. Okay, so that's it for today now, and hope you enjoy this full tutorial. And make sure that you subscribe our channels and give me support that, so that I can continue the series as well. Okay, and also pray for me because I have क्या बताऊँ आपको, थोड़ा प्रॉब्लम है वॉइस का इशू, इसके बाद थोड़ा कॉफ खांसी ऐसे लग जाता है। ओके, क्योंकि ठंडा का मौसम चला है ना, इसलिए। ओके, सपोर्ट मी एंड प्रे फॉर मी। ओके, थैंक यू, बाय बाय, एंड आई विल बी बैक विद द ट्यूटोरियल। सो टिल देन टेक केयर एंड बाय बाय।